Okay, now I think I'm recording. Okay, perfect. All right. Yeah. So I'm gonna start with the section. So this is okay. I need to turn on my pen. Okay. Okay. So this is section 1.1. Okay. So and I'm gonna talk about what's statistics actually. So what's statistics? Okay. So, I mean, in today's world, guys, statistics is actually everywhere. For example, you have customer surveys, you have political polls, you have economic predictions, sport statistics, right? So they are just everywhere, right? So today, you see my writing, guys, right?
Yes.
Okay, perfect. Sounds good. Thanks. So yeah, in today's world, statistics are just everywhere. And examples. So for example, so as I said, for example, customer surveys, political polls, as I said, economic predictions, etc. So there are just plenty of examples where we use statistics. So yeah, so the question is, as you said, I mean, what's the statistics, right? What's the definition of statistics? Well, roughly speaking, statistics is just a way to get information from data. That's like roughly speaking. Okay, so if someone asks you what's statistics, we can just answer. It's just a way to get information. You have some data, right? You have numbers, and statistics is just the way to get information from your data, from the numbers, right? So yeah, so so what's statistics? So roughly speaking, it's just a way to get information from data. So it's a way to get information from data. Okay, so when I say data, guys, I mean just numbers. Okay, so like if you have customer surveys or polls or economic predictions, so you have some data, you have some numbers, and you're gonna try to extract. You're gonna try to get some information from your data. Well, so it's a way to get information from data. It's also the study of how to collect, organize, or analyze numerical information from data. Okay, so it's all about data. It's all about numbers. Yeah, so statistics is just is the study of how to collect, organize. So we're gonna see like in the next section, the first way how to organize data or numbers with the frequency tables. But anyway, so it's the study of how to collect, organize, analyze, numerical information from data. I mean, nowadays data is very, it's very expensive. all you want to do is to get data from, from people. You want to get some information from people, right? You're like on Facebook, you are in, I don't know, Instagram, right? And you put all your informations in Facebook or wherever, right? So then all your information, your personal informations are just data, right? They're just numbers, and we can use this data to actually, to get a lot of information, right? And that's exactly statistics. So yeah, so in general, how to gather the data. So how to gather the data. Okay. By the way, guys, I mean, if you have any question, you can write down your question in the chat. Okay. I mean, again, please feel free to interrupt me anytime. All right. Because sometimes I don't see the chat, so you can unmute yourself. Feel free to unmute yourself and ask your question. Okay. Yeah. So how to gather data? First, we're gonna need individuals. So first. So we're gonna need individuals. Okay. And so what do I mean by individuals? Well, individuals are just the people or objects included in the study, right? So for example, you study, I don't know, let's say the average age of New Yorkers, right? So the individuals in your study is going to be just New Yorkers, right? So individuals are just the people, or the people, or the objects included in the study. Okay. I'm going to give you a couple of examples in a minute, but let me just say one more thing. So we have individuals to gather the data. You need individuals, and you need, of course, the variable. So the variable is, so the variable, that's the characteristic of the individual to be measured or observed, right? So the variable. So there's the variable. That's the characteristic of is, this is the characteristic of the individual. To be measured or observed. For example, you want to compute like the average income of New Yorkers, right? So the individuals will be the New Yorkers, right? And the variable, so you want to measure or want to compute the average income of New Yorkers, right? So the variable would be the income, right? So of the individual to be measured or observed. To be measured or observed. Okay, so let's have a couple of examples. So examples. Well, let's say my first example is we want to study, for example, the GPA of the students in BCC, for example. Okay, so we want to study GPA of the BCC students. Okay, so here we are interested in the GPA of the BCC students, right? So what would be the individuals in this case? What would be the people here? Students, right? Exactly, students. And what will be the variable?
The GPA.
The GPA, absolutely. So very good. So the individuals here are the students. And the variable is just the GPA. Another example. So that's the first example, second example. So let's say we're interested or we want to study. So we want to study about the people who have, let's say, climbed the mountain, the top of the mountain. Okay. So we want to study. Let's say we are interested in the, let's say the age of the people who climbed the top of the mountain. Okay. So we are, what will be the individuals in this case?
The people.
Yeah, the people who climbed the mountain, not all the people, of course. Not it's the people who climbed the mountain, right? And the variable?
Age.
The age, absolutely. So the individuals are just the people who climbed the mountains. The top of the mountain, and the variable is just their age. Right, because as you can see here, we are interested in the age, right? The right here, the age of the people who climbed the mountain, right? That's of the variable is the age.
So is this about graphs? We're going to be using graphs?
Well, yeah, we're going to have some graphs later. Yeah, yes, we're going to have some graphs. So because at some point we need to organize the data. So yeah, we're going to graph. We're going to have some graphs. Yes. All right. Now there are two sorts of variables. Actually, there are two kinds of variables. There is the quantitative variable, so expressed as a quantity, right? And there is a qualitative variable. Okay. So we have two two sorts of variables. I can probably move to the next page. Sorry. Okay, I gotta just go down here. All right, so there are two. I mean, this is just this section is just like a very general introduction to statistics, right? So we're gonna just introduce some some definitions, some notions like so like here that we have the individuals, right? The variable, etc., right? But after that, of course, we're gonna be more specific, right? But this first section is like very general, just like we're gonna introduce some definitions. We won't do any computations here. So yeah, so I was saying there are two sorts of variables. Okay, so first we have, as I said, we have a quantitative variable. So in the word quantitative, guys, you can see the word quantity, right? So it's expressed as a quantity, right? It has a value or a numerical measurement, right? It's a number, right? So this is just so this variable here, it's expressed, and usually it's expressed as a number, right? So so quantitative variable, it's expressed as a quantity. Okay, and so I mean it has a value. It's just a number. It has a value or a numerical measurement, right? Or a numerical measurement. Okay. Yeah, so when I say value here or numerical measurement, I mean a number. It's just a number, right? For which, operations like addition or multiplication or whatever makes sense, right? So it's just a number, for which a numerical measurement for which operations like addition make sense. Like addition or subtraction or wherever addition makes sense. Okay, so just keep in mind, so when I say quantitative variable, it means it's a number. Variable can be expressed with a number. Okay, it's just a number. And then, yeah, so we have quantitative variable, and then we have qualitative variable. Qualitative variable. So qualitative variable, obviously it's not a number, actually describes, describes an individual by, placing the individual into like a category or a group. For example, I don't know, like for example, gender or race or, or color or wherever. Okay, so this is not, it's not a number. So this is, describes an individual by placing, so you place the individual into like a category by placing placing the individual into a category or a group. Okay. For example, such as, for example, a female, etc. So, for example, so I'm going to give you a couple of example. So, example. I guess I need to meet someone. Yes, Edward. I'm sorry. I now I see you raise your hand. Probably I'm too late.
Yeah. Oh, it was regarding the calculator.
Oh yeah. Okay.
We
No
could
problem.
discuss that after, but keep going. Keep going.
Okay.
I could ask you
Yeah, I
later.
think I discussed the calculator, but yeah.
No, no, I wanted to. It was a question regarding the calculator, but we'll talk later.
Okay. Okay. I mean, I can probably answer your question after the lecture. Okay. Sorry about that, because guys, I'm using my iPad and I don't see the chat. So sometimes just I miss the question. All right. Sorry. Yeah. So I said examples. Yeah.
Your child's education. Watch State of Our Schools. Only on News 12.
Okay. I think. Oh yeah. Okay. Sorry, guys. I think I had to mute someone. Okay. Examples. Yeah, I was saying. So first example. Let's say the color of a person's eye. Okay. The color of a person's eye. So do you think this is quantitative or qualitative variable?
Like
Qualitative.
Yes. Okay. It's not a color. It's not a number, obviously, right? So yes, it's just a qualitative variable. Okay. Let's see. The height of a person. in inches, or let's say the height of a person in inches, for example. Right? So what do you think? Is this quantitative?
Qualitative.
Quantitative.
Yeah, quantitative. Yes, absolutely. This is a quantity. It's a number, a height. It's expressed with a number. So absolutely, yeah. Variable. Right.
How do you know, since, if it's quantitative or qualitative?
Yeah,
Because
so yeah, go ahead.
the color, it did not show a color, and the height, it did not give you a number. So how will I know?
No, so the height of a person is expressed with a number, right? For example, you're let's say you're 6 feet tall, right? It's a number, right? The height
Yeah.
of a person, it's expressed with a number. So if you have something which is expressed with a number, then it's quantitative. Okay, quantitative means a quantity. It's a number. It has a value.
Okay.
Okay, when it's
Numerical. Okay.
yeah, numerical. Yes, as you can see here, numerical. So it's a number. Mhm. And yeah, and then qualitative. It's not obviously. It's not a number, right? So something which describe an individual, which is not a number. So, for example, it would be, as I said, it would be like a gender, race, or
Yeah, I understand now. Got it. Thank
Mhm.
you.
Sure. So a color of a person's eye, of course, it's not a number. So it's just it's a qualitative variable. One more example. The income, let's say, the income of a New Yorker. Okay, so the income, that would be, you think it's
Quantitative.
Yes,
A
absolutely.
quantitative.
Yeah, yeah, that's a quantity, that's a number. So that's quantitative variable. Okay. Any questions so far, guys? So
Hey,
again,
this is Jasmine. I have a
Jasmine.
question.
Yeah, please.
All right. So the fact that you said it was a quantitative because you said the income of a New Yorker, if you would have said how many incomes of a New Yorker, would that have been the qualitative?
Yes.
Okay.
So here by income, of course, I mean, yeah, like, I mean, like the number. But yeah, for sure, yeah. So yeah, so let me just remind you what we did. So we said first we said what's statistics, right? So statistics in general, it's just the way to get information from data. And when I say data, guys, I mean numbers in general. Now, to get the data, of course, you need individuals. For example, are interested, as I said, you are interested in New Yorkers. So the individuals here would be New Yorkers. You are interested in, I don't know, in the students. So in the GPA of the students. So the individuals would be students, right? And then you have the variable. That's the variable. That's the characteristic to be measured or observed. Right? You want to measure. I think there is a question in the chat. I'm sorry. Oh, okay. Yeah. So yeah, I was saying the variable. So it's the characteristic to be measured or observed, right? You are interested in the GPA of students, so that the GPA would be your variable. You are interested in the height of New Yorkers, so then your variable would be the height, right, etc. Now, another important issue in the source of the data, right? So you need individuals, you need the variable. There's another important issue. That's the source of the data. So another important issue is the source, the source of So this is very important, actually, the source of the data. So we have two different two sorts of sources. So we have population data. Population data. Okay, so population data, guys, means that the variable is from every, it's from every individual of interest, right? So it's from every individual. So for example, you're interested in the income of New Yorkers, okay? Then your data is from every New Yorker. That would be a population data, okay? So the variable in the population data, the variable is from every. So the key word here is every. From every individual. Okay, every individual of, let's say, of interest. Now, so we have population data, but we have also sample data. So sample data so in the sample data, so we have the variable, it's not from every individual, it's only from some of the individuals, okay? So the variable is from some of the individuals. The variable is from some of the individuals, not all of them. So all of them, that means it's a population data, okay? Individuals. Okay, of interest.
So basically, when you say some of them, that's as if you were like breaking it up into groups?
Yes, it's not all, yeah. So yeah, yep, that's a good point. So like, for example, yeah, let's use the same example, the income of New Yorkers. So if your data is from, let's say, just people living in the Bronx, okay, so let's say you are interested in, so here we study, let's say we study the income of all New Yorkers, okay? Of all New Yorkers. Now, let's say your data is just from for people living in the Bronx, okay? So your data is just from people living in the Bronx, okay? Okay, so in this case, this is not, it's not from your data, it's not from all New Yorkers, right? It's just from people living in the Bronx. So in this case, this is not, it's not a population data, this is a sample data. So your sample is the people living in the Bronx, right? So the sample here, so this is a sample data. This is a sample data. Okay,
Professor?
Yes.
It's a bit confusing when you say all of New Yorkers, because New York does have 5 boroughs.
Yes,
So I
yes.
feel like it would have been easier if you said we study the income of all New Yorkers, like from the Bronx, from
city.
all New Yorkers. Is this seems a bit confusing? Like you was
No,
about
no,
to
no, no, no,
populate-
no. I mean what I meant, actually. So here we're trying to study the income of all New Yorkers. So what I mean by all New Yorkers, of course, it's the 5 boroughs. It's Bronx, Queens, etc. Right?
Mhm.
But your data, your numbers, the data you have, it's not from all New Yorkers. It's just from the people living in the Bronx, right? So that's not, so then your data, doesn't cover all New Yorkers, right? So it's just cover people in the Bronx. So that's a sample data. It's not the population data. It's not from every individual in New York. in New York City, of course.
What makes
It's
it
just-
a sample data, even though it says all New Yorkers, it's like looking at the big picture and then on the bottom it says living in the Bronx.
Yes,
That makes it the sum.
yes. So all New Yorkers, of course, I mean, let's say Bronx plus Queens, Manhattan, etc. But your numbers that are not from all New Yorkers are just from people in the Bronx. So then your data, you have a data, you have some numbers, right? You have some information, right? But your information is just from the Bronx. It's not, it doesn't cover all New Yorkers in New York City, right?
Right, that's what make it sample data.
Sample. That's what makes it sample,
The
not the population.
population data would be every borough.
Yeah, every borough. Yes, that's what I mean. Yes, population data, it cover every borough. Yes, absolutely. Yeah, so this is a sample data.
No, I understood that. I'm just saying, when you put all,
Mhm.
right? That's what kind of threw it off. I thought you wanted us to put, okay, we studied the income of all New Yorkers. I thought you wanted us to put population, then you put data is from people living in the Bronx. I thought you wanted us to put sample for that one. Like, you understand? I thought those was two separate questions.
No,
basically.
no, that's not separate questions. Yeah.
Oh, okay.
Yeah, that's not separate questions, actually.
Okay.
Yeah. Yeah, that's not separate. Yeah. So we are trying to study, right, the income of all New Yorkers, but then it turns out that our data, it's not from all New Yorkers, just from the people in the Bronx. So that's why it's a sample. Yeah. Any other question, guys? Right. Let me give you more examples. Okay. Two. Let's say you want to study. Let's use the same examples as before, the GPA of the students. So we want to study the GPA of BCC students. Okay. And let's say your data is let's say from sophomores. Okay. So so we want to study the GPA of all BCC students, right? You want to try to, I don't know, let's say you want to compute the average, the average GPA of all BCC students, right? But then your numbers, your data, it just cover the sophomores, okay, in BCC, right? But of course, the sophomore students, it's not, doesn't mean that's not all your students, right? You have a freshman, et cetera, right? So this is, so in this case, do you have population data or sample data? The data we have, the numbers we have.
Sample, sample data.
Yeah, absolutely. It's just a sample data. Absolutely. So yeah, that's the idea here. So if your data is just from a group of people or a group of the individuals who are interested in, so that will be a sample data. So sample data. One more example. Let's say we want to study, let's say the age of let's say all individuals who climbed the, let's say the top of the mountain. Okay, and now your numbers or your data is from every individual, from every individual who made it to the top of the mountain, right? From every individual who made it to the top. To the top of the mountain, right? So in this case, is our data, is it a sample or population data?
Population.
Yeah,
Population.
data because cover everyone, right? Absolutely. So this is a population data. Okay, so what you have to keep in mind, guys, is that there are two sorts of sources, right? So we have the population data and you have the sample data. Population data means that you have the data from every individual of interest, right? And the sample is just from some of the individuals, okay? That's because, it makes a huge difference when you have a sample data or population data. It's all about how the data is precise, right? Yeah, so one more thing. So we have the population data, we have the sample data, and then the variable. So when you have a sample data, if you have a variable, then it's called actually a sample. It's called a sample parameter or sample statistics. And if you have a variable from population data, then it's called actually a population parameter. So let me just define here what I mean by population parameter and sample variable. So here are a couple of definitions. So depending on the data, if you have a population or sample data, then you have a parameter, a population parameter. Okay. So population parameter, this is when the variable is from a population data. So the variable is from a population data. Okay. And then you have a sample parameter or a sample statistic. Okay, and this is when we have a variable from a sample data. Okay, so the variable is from sample data. Okay. Anyway, so guys, later we're gonna distinguish between when we have the population data and when we have a sample data. So it's important to understand the difference between population and the sample data, right? Any questions so far, guys? Let me check the chat. I'm sorry, I can, let me see the chat. All right, okay, no questions. Okay, good. All right, so next we're gonna learn how to organize data, okay? So next, oops. Okay, so next, so we're gonna study frequency tables and histograms. Okay, so this is actually section, if I'm not mistaken, this is actually section 2.1. Okay, sections, if you take a look to the syllabus, we are supposed to do sections 1.2 and 1.3, but 1.2 and 1.3, they're all about definitions. So whenever I need some definitions from section 1.2 or 1.3, I'm gonna do them. Okay, yeah, we can probably just we can move to the section 2.1, and if I need anything from previous sections, I will let you know. okay? But let's yeah, so let's jump to this section 2.1. So in this section 2.1, we're gonna learn how to organize and represent the data, okay? So the goal of this section is to learn how to organize, okay, and represent data. Okay, so what we're gonna do, guys, I'm gonna do an example, and with the example, I'm gonna show you all the steps to make this frequency table. Okay, so I'm gonna start with an example. So in this example, so at the same time, I'm gonna do the example with definitions. Okay, so example and steps. So steps to make the frequency table. All right, so let's say we have the following data. So let's consider the speeds of, the speeds. So this is in miles per hour. Okay, of let's say we have 24 cars, 24 cars, okay, on a highway. Okay, so here, what I'm doing here, I'm interested, I want to study like the speed of the cars on some highway. Edward, you raise your hand. Yes.
No, that was from earlier.
Oh, that's what. Okay. I don't know. I got your, again, you know, the hand raised here. Okay, no problem. So I have 24 cars on the highway, right? So this is, in this case, I don't have all the speeds of all the cars on the highway. That's probably impossible, right? So here we have sample data, right? Because we have only 24 cars here. That's not like all the cars on the highway, right? So in this case, we have this is a sample. This is a sample data, right? Because it's just 24 cars. It's not all the cars on the highway. Okay, this is the sample data because this is only 24 cars. So it's not all the cars on the highway. Okay. You know, sometimes it's just it's impossible to have like population data, right? So for example, as I said, for example, we're interested in the income of New Yorkers. You cannot just, I mean, I don't know, I'm not sure, but probably IRS would know the income of all New Yorkers. But I mean, it's kind of really hard to gather, you know, the data from all the population, right? If you have like, if you have a population of 8 or 10 million, right? That's a lot of people, right? So sometimes, you know, well, I would say it's most of the time we have only a sample data, not the population data, right? I mean, you can imagine you wanna if you have a population of 10 million, that's a lot of people, right? So usually we use sample data. But anyway, so in this example, we have 24 cars on the highway, so that's a sample data, all right? And so we have the following data. So this is like the speed of the 24 cars. So we have so the first car, the speed of the first car is, let's say it's a 43 miles per hour. And then second car, we have 70. So we have 24 cars. So that's when we're gonna have like 24 different numbers, right? We have 75, 80, 83, 86. Here we have 66, 71. 79, 80, 83, 86, 67, 71, 79, 80 again, 86, 88. So how many? We have 6 times 3, that's 18. So they're still missing 6 cars. So 69, 71, 79, 81, 86, and 88. Okay. So we have the speed of 24 cars, right? So this 24, this 24 numbers, this is my data. This is what I call data, right? That's like the numbers I have. That's like the speed of my 24 cars, right? So this is my data. Since this is what I call my data. The sample data, right? I measured the speed of 24 cars, only 24 cars, not all the cars, of course. Okay, so I got these numbers, right? And so that would be my sample data. It makes sense to you guys? So far, so good?
Yes.
Okay, cool. All right.
Yeah.
Now, okay. Now, so what I'm gonna do with these numbers. So these numbers are my data. And now I'm gonna try to organize this data, right? I need to find a way, to represent or to organize this data, okay? So we're gonna use, so next, I don't know, of course, we won't have time to do this today, but I mean, I'm gonna show you like at least the first or second step, but so now what we're gonna do, we're gonna use frequency tables. So now the goal is, I'm gonna probably write now instead of next. So now, so we're gonna use, so I'm gonna show you how to organize such a data. Use frequency tables to organize organize. So in this case, what will be the variable of what will be the variable of this sample data? Any guess?
The numbers in the box?
Yes, the numbers on the
Yeah,
box. That's the variable. So the variable here is the speed of the car, right? That's our variable here. We're interested in the speed of 24 cars. So the individuals here is the 24 cars, okay? And the variable, that's our numbers, and that's the speed of the car, right? So, so we're gonna use frequency tables to organize our sample data. So yeah, so let me just say, so in this case, or this example, so the individuals here, so here we don't have like we don't have like people. Here we have objects, which are the cars, right? So the individuals here are the cars. So we are interested in the speed of the 24 cars, right? And the variable, okay, so these numbers are my variable, and they represent just the speed of the car, right? So the variable here is just the speed. It's the speed of the car, or the speed of cars, okay?
I have a question, right? So an individual could be a person, place, thing.
Yes, that's the thing.
Okay.
In the definition of individuals, we said it's the people or objects.
Okay.
They don't have to be like people. They can be like in this case, they are cars, right? I don't know, Edward, did you raise your hand again? But I don't know. It's like it's still.
No, it won't let me put my hand down.
Okay. Okay. Well.
Put the cursor over it, the mute and rename comes up.
Okay, because I don't know. Your name keep,
Oh, never mind. I found it. Look, lower hand at the very bottom.
Okay.
Okay.
I'm so sorry about that. Yeah, so the variable, the speed of the cars, and yeah, so we're gonna use a frequency table to organize the sample data. So what we're gonna do, we're gonna use this frequency table to partition data into classes or intervals. Okay, so we're gonna use So use frequency table to partition the data into classes or intervals. Use frequency table to partition. So we're gonna divide the data into intervals, okay, or into classes. Use frequency table to partition the data into classes, or they're called classes, or they're called intervals. Intervals. Okay. So first step. So I have this data. I want to organize this data using a frequency table. So first step is you need to determine how many classes we want, okay, or how many intervals we want, right? So we're gonna divide all these numbers into, I don't know, 5 or 6 classes, right? So first step is, so step 1. So you have to determine how many classes or how many intervals we want. Determine how many classes or intervals we want. So in general, guys, I mean, in the exercises or in the, I mean, in the test or in the homeworks, the number of classes or intervals they are is given. Okay, the number of classes or intervals is given in general. Okay, so in general this is given in the problem. So in general, this is given in the problem. Okay. So let's say, like in this example, we want, let's say, 6 classes or 6 intervals. So I'm going to divide this data into 6 classes. Okay. So in our example, let's say we want, let's say, 6 classes in our example. Okay. Then next step, once you know how many classes you want, all right, next step, you need to determine the class width. Okay. Step number 2. So we need to compute. So this is the first thing we need to compute, actually. We need to compute the class width. Okay. So how do we compute the class width? I mean, what do I mean by the class width? The width is like, the class width is like the length of the class. Okay. So so the way to compute the class width is we need to take, so to compute the class width. So first you need to subtract. So you need to take the largest data value or largest number in your data. So largest data value or largest number in your data minus the smallest one, Okay, you subtract, you take the difference, and then you divide by the number of classes. So here you divide desired number of classes. You divide by the number of classes. Okay. Now we are not done yet, because so the answer here, that's not exactly with the width. So you need to take the width would be the next. So this is a next step. So the width would be the next the width would be the next higher integer. I mean, even if your answer is a whole number, but the width would be the next whole number or the next integer. Okay, so even if the answer is 1, is a whole number. So that's what I mean by integer, guys. Integer, I mean the whole number, right? Integer, that's a whole number. Okay, so even if the answer in the first step, so even if the answer in 1 is a whole number, you need to take the next one. Next whole number is a whole number. All right, so in our example, so let's compute the width in our example. Okay, so oops. All right, so in our example, okay, so we're gonna compute the width, right? So let's compute the width. Okay. Step, we need to take the difference between the largest data value and the smallest one, right? And then divide by the desired number of classes. So what's the largest? We need first the largest data value. So what will be the largest number here?
88.
88, thank you. So as you can see right here, 88 is the largest data value or largest number or largest speed, right? Now, what will be the smallest speed or smallest?
43.
Thank you, 43, right? So to compute the width, we need to take the difference, 88 minus 43. So it's 88, right, minus 43. And then we need to divide by, as you can see here, the desired number of classes. How many classes we want? Well,
24. Or
mm,
6.
6. We said we have 24. Sorry, we have 24 cars, but we want 6 classes actually. So as I said, the number of the classes is given in the problem. The 24 cars, that's the size of the sample, right? We have 24 cars. The sample is given by the speed of the cars, right? So 24, that's the size of the sample. That's not the number of classes.
Sorry, I have a question
Yeah, please.
before you continue. What decides how many classes are there? It will be like part of the problem, or what determines to be 6 classes?
Yeah, that's why. Yeah. So what I said, in general, the number of classes, it's given in the problem. So it will tell you, like in the problem, we want let's say 6 classes or 5 or 8 or wherever. Okay, so it's given. It's in the it's in the question, right? It's given. Okay. Makes sense?
Yes.
I will tell you. I mean, the problem is going to tell you, well, we want 6 classes in this problem. Okay, so it's given. The 24, as I said, 24, that's not number of classes. 24, that's the size of the sample. So we want 6 classes. So we need to divide by 6. So because we want 6 classes in this problem. Okay. So let's compute this thing. Of course, guys, first, when you need to subtract first, right? You need to compute the difference between 88 and 43.
Yes.
So 88 minus 43, that's 45. Thank you.
45.
Over 6, right? And then you need to use our calculator.
Divide by 6.
Yes, it's 745 by 6. That's 7.5, right?
Yes.
It's 7.5. Okay. Now, 7.5, that's not the answer. That's not the width. So what we need to take as a width, so the width would be the next next integer, next whole number.
8.
So like you have your, you have your number line. This is your number line. You have 0, 1, 2, etc. Right? You have 7, let's say 8, right? And then the answer here, the result here is 7.5, right? So here's your 7.5. Okay. Then the width would be the next whole number, which is
8.
8.
Thank you, which is 8. Okay. Now let me just say, guys, so the width, so here the answer, the width. So the width would be 8. So let me just finish with this remark, guys. Let me just say, so if your answer, it's a whole number, for example, let's say for some reason, I mean, you have different example, right? And for example, you have like 88 minus 40 over 6, okay? Let's say we have a different example, right? Where the smallest data value is 40, not 43. And so you get 48 over 6. So the answer here is 8, right? 48 over 6, right? Now the width, it's not 8. The width would be the next integer. So the next integer is, or next whole number is 9. Right, 9. So the answer, so then the width, in this case, the width is, it's 9, okay? So just be careful. You need to take, anyway, even if your answer is a whole number, your answer, the width would be the next integer.
Okay.
Why?
Okay. All right, guys. Sorry. So I'm gonna stop here, right? And tomorrow, I guess we're gonna continue with this frequency table. I'm gonna show you all the steps and how to make this frequency table. All right. So thank you, everyone, and I guess I will see you tomorrow. And of course, if you have any question, I'm still available.
Somebody asked the question.
Oh yeah, that's what I'm seeing. Yeah, Kayla, you said why is it 9? Yeah, that's what I said.
All right, because I'm just confused. I'm not gonna lie.
Yeah, sure, no problem. So
I got lost like
yeah,
a little
so-
while ago.
yes, okay. So what I was saying is, so you take this difference and you divide, right?
Mhm.
You got 8, right?
So wait, so I'm gonna do the bigger number and then the smaller number.
Yes.
You do the
Yes.
subtraction
Yes.
and then you put the, the whatever you want, the 6 classes at the bottom.
Yeah.
And then whatever you have, like the 48 over the 6. So you divide
Yes.
6
Or-
into 48,
Yes.
and then that's 8.
That's 8.
So
And
how come
now-
it becomes 9?
That's what I'm saying. The width is always the next higher whole number. Even if
Okay, all right.
even if your answer is a whole number, the width will be the next number, next whole number. Okay.
Okay.
That's what I said here, right here. You see here, even if the answer 1 is a whole number, even if your answer is a whole number, the width would be the next.
Oh, okay.
Makes sense now?
Yeah, I'm gonna rewrite that. I don't know what happened there. All right, thank you.
Any other question, guys?
Yeah, I have a question about the
Yes.
calculator.
Yes. Yeah.
Because I looked it up. Does it have to be Texas, or that's the particular one, the Texas one?
No. I mean, it's a, it's
Texas T Pro, whatever.
No,
it
that's
was.
that's like my suggestion. Like that will be like the
But
best. That would be
that's-
like that. Excuse me.
No, go ahead. I'm sorry.
Yeah. No, I'm saying that's like just my suggestion, right? This is like that. Well, that would be like the best calculator, but it can be it could be a different one. I mean, it doesn't have to be that one. Yes.
Hello?
Yes, I hear you.
Yeah, I just want to know, when you said even if your answer is a whole number,
Yes.
the width will be the next whole number.
Yeah.
Is that every time?
Yeah, every time. Yes, every
Okay,
time.
thank
It's
you.
not specific to this example. It's every time.
Okay, thank you. Have a
Professor,
good day.
Yes, Edward.
How do you say your name? Professor what?
Lejmi.
Lejmi. Okay, got it.
Mhm.
All right, thank you.
No problem. Sure. You're welcome. The homework, no, it's not, the homework is going to be due like next, well, there is no homework yet, but when I post the homework, so usually the homework, it's due next week. Like if I post the homework, let's say on Wednesday, then it's going to be due the Wednesday next week.
Okay.
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 I
Thank
mean,
you.
I the due date, is going to be on CUNY Blackboard anyway, so you can see it on CUNY Blackboard.
When are you posting the homework?
Probably this Wednesday. The first homework is going to be probably this Wednesday. Mhm. Can you the name? It's in the syllabus, Yanin. I can probably stop sharing my board. Let me see here. So let me just share the syllabus. Share the syllabus. Okay. Here. Do you see the syllabus here?
Okay, I
Says-
see it.
Mhm.
Thank
And
you.
again, it doesn't have to be this particular one. It can be it could be something different. But and again, if you need help, because you need to know how to use your calculator. That's really important. So if you need help using your calculator, just let me know. We can meet online, and I will try to do my best to help you. Okay.
Okay.
All right, guys.
Are we allowed to use our calculator for
Oh
homework?
yeah, of course, of course.
Really? Can we use it
Oh,
on
yeah.
a test too?
Oh yeah, yeah, all the time. You're allowed.
Really?
This is all about computations. There's going to be a lot of. It's not about it's not really about computations. This course is more about to know which formula you need to apply.
Oh, that's
You're gonna
good.
have like plenty of formulas, and yeah, of
So
course.
as long as we know how to use the calculator, then we could basically pass this class with an A.
Oh, now as I said, you need to know which.
No,
We're
it's
gonna
more
have
like the
like plenty of
formula.
formulas. You're
Yeah.
gonna have like bunch of formulas,
Oh,
and you need to know which formula you're gonna apply. And that's the trick. I mean, that's the problem. It's not to compute the numbers.
yeah, but if you know the formula.
Oh yeah, yeah. Oh yeah. If you
Then
know,
I
the
mean,
formula,
like,
then you're good. Yes.
okay, that's nice. All right.
Yeah.
Thank you. Have a great day.
You too.
All right.
Yeah, you too. Any other question, guys? Nope. Okay. Well, then I will see you tomorrow. Take
All
care.
right, thank you,
everyone.
Professor.
Bye.
See you tomorrow.
Thank you, everyone.
Okay, thank
All
you so
right, bye, Professor. Thank you.
Bye.
Bye.
Nice meeting you guys. See you tomorrow.
See you tomorrow.
See you tomorrow.